Hey Algebra 1, thanks for tuning in. And today we're going to be looking at 9.1 Part 3, Adding and Subtracting Radicals. We're going to look for 5 things to go on our notes today, so let's go ahead and get started. The first thing we want to know is how to exactly add and subtract radicals. So I have 2 examples here, and it does seem like a lot of information, but it's actually pretty easy once you catch on. The first thing you want to do is make sure that you can show the commutative property of addition, which in a sense here we've just paired up matching radicals with their quote unquote coefficients. So how we have like 5 times the square root of 7 can match with the negative 8 square root of 7. We're just going to switch that around so that they're close to one another. Once you have them close together, then you can use the distributive property. 5 and a negative 8 would make a negative 3. So you would have negative 3 square root of 7 plus the square root of 11. Another thing we can look at is what would happen if we didn't have any matching radicals, to see if we could possibly make a matching radical. And this is going to go back to a previous lesson that we've already seen. If we had 10 square root of 5 plus 20, or square root of 20, we could break down that 20 and say square root of 4 times 5. That would help us because then we could have matching square roots of 5 and then maybe solve the square root of 4. Square root of 4 is going to give us 2, so we'll have 10 square root of 5 plus 2 square root of 5, and when we add those together we can get 12 square root of 5. If square root of 5 was by itself, we just operate as with a 1 in front of that, so 1 square root of 5, or if it was like this, the negative square root of 5, that'd be negative 1 square root of 5. So just make sure you understand that separate piece as well. I'm going to go ahead and give you time now to pause the video here so you can write down the examples you see, and then once you're done, click play so you can try some on your own. Alright, so here's questions 2 and 3, and remember what we're going to look for is matching radicals that we can combine like terms. So maybe you even want to think about that as like term. So what you're going to try for 2 and 3 is to try to get the like terms ready and set, and then go ahead and combine them, finding your correct answer. So let's go ahead and pause here so you can try 2 and 3, and then once you're done, click play. Alright, so for number 2, I already had 2 like terms, so I'm going to go ahead and combine those. I have a 3 square root of 2 and a 10 square root of 2. So if I combine those, I'll get 13 square root of 2 minus the square root of 6. The square root of 6 cannot be broken down so that I can also have a matching square root of 2. So this is my final answer here. 13 square root of 2 minus the square root of 6. For number 3, I don't have any matching square roots, so what I'm going to have to do is try to break one down if I can. And I can do that with the square root of 63. I can take the square root of 63 and make it a square root of 9 and a square root of 7. So I'm going to go and write that and bring everything else down. So 4 square root of 7 minus 6 square root of 9 square root of 7. The nice thing is that I can also take the square root of 9 and solve it. That's 3. So now I'm going to have this. The 4 square root of 7 stays the same, minus 6 times 3 square root of 7. 6 times 3 is going to give me 18, so now I have 18 square root of 7. Bring down my minus sign, and then a 4 square root of 7. Now I'm just simply going to combine 4 and negative 18. That's going to give me negative 14, and then keep the square root of 7 the same. So that would be my answer for number 3. The next thing we're looking at is something we've already talked about as well. What we're going to do is multiply radicals, and this essentially is going to go back to the distributive property. What we'll do here is go ahead and distribute the radical of 5 to both things inside the parentheses. So I'm going to have the square root of 5 times the square root of 3 minus the square root of 5 times the square root of 75. And then I'm going to multiply these together. 5 times 3 is 15, so I have the square root of 15 minus 5 times 75, that's going to be 375. Now what I want to do is just to make sure, now I can go ahead and go back to what I was doing before, which was subtracting the radicals. And so I want to make sure they have something in common. 15 does have something in common with 375. I can break up 375 by doing the square root of 25 times the square root of 15. So I'm just going to bring that down and then go ahead and simplify first and then subtract. So I have go and write my steps down to the side so you can remember what I'm doing. Square root of 25 is 5, so I have 5 square root of 15, still bring my minus, and then my first square root of 15. This is where I can combine because I have matching radicals. Remember, if there's no number in front of your radical, you can easily plop down a 1. So that makes it a little bit easier to combine here. So technically I'm doing 1 minus 5, which is negative 4, and then keeping the radical or the square root of 15. So that would be my answer for this one. So here's the last two that you're going to try. Again, remember you're going to distribute to everything inside the parentheses, and then once you're done, click play to check your work. Notice number 5 is a little different because you got an exponent. So let's go ahead and pause here. Alright, so for number 4, the first thing I actually did was I broke up inside the parentheses first, and then I will take my distribution and do it correctly, just because I already have 2 sets of radicals. So the square root of 32 can be broken up to the square root of 8 times the square root of 4. So I have 8 square root of 2 plus 7 square root of 8 times 4. Still with the 3 on the outside. Even better, because I want to match up that 2, I'm actually going to pick square root of 2 and square root of 16. So I can match this 2 up with this 2. Square root of 16 can be simplified to 4. So I have 7 times the square root of 2 times 4 plus 8 square root of 2, all times the square root of 3. And the nice thing here is I can go ahead and multiply 7 times 4, because those are 2 normal numbers. So I have 8 square root of 2 plus 28 square root of 2 times the square root of 3. Then I can go ahead and add 8 and 28. It's going to make 36 square root of 2 times the square root of 3. And then what I'm going to do here is go ahead and just multiply my square root 3 times my square root of 2. So I have 36 times the square root of 6. No need to multiply the square root of 3 times 36, because then you'd be able to simplify that and it'd be right back to 36 is your answer. For number 5, we want to go ahead and write this in expanded form. So that's what I'm going to do here real quick. And then what I'm essentially going to do here is FOIL, similar to what we learned back in chapter 7. So when I FOIL, I'm going to get 2 squared times the square root of 5 squared minus, then I'm going to do 2 times negative 4, that's minus 8 square root of 5, and then another inner minus 8 square root of 5, and then negative 4 times negative 4 is a positive 16. Now I'm going to go ahead and simplify anything. So 2 squared is 4. The square root of 5 squared is 25. The square root of 25 is 5. So it'll be 4 times 5. And then this negative 8 square root of 5 minus 8 square root of 5, that's negative 16 square root of 5. And then plus 16. I'm going to go ahead and multiply 4 times 5, which is 20. And bring everything else down. And then I'm going to go ahead and combine 20 and 16 to make 36. So I have 36 minus 16 square root of 5 left. And my square root of 5 can't be simplified anymore to break it down, nor can it be added with anything else. So here's my final answer, 36 minus 16 square root of 5. That's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.